Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 says, in an electron gun, electrons are released from a heated filament. Which of the following is the name of this process? So in this case, electrons are released from a heated filament. So simply we can write down this is emission of electrons. We can simply write down this is emission of electrons due to heating. Electrons due to heating. And this process we call is thermionic emission. Thermionic emission. So this is thermionic emission. Thermionic emission. So the answer for this question has to be T. Thermionic emission. Photoelectric effect. This is emission of electrons. So we can try to understand a little bit more about these processes as well. Emission of electrons due to light. Photo means light. So simply we can say due to light. So that process is called photoelectric effect. Thermionic. So you can see here thermal. Thermal means thermal energy, heating. So we can say thermal energy. So like this you need to understand physics. Ionization. Ionization is the formation of, or simply we can say process by which ions are formed, or we can say forming of ions by losing or gaining electrons. So this is a general term. By losing or gaining electrons we can call that is ionization. So ionization means the process by which ions are formed. That process is called ionization. How ions are formed? They lose electron or they gain electrons. And annihilation. Annihilation is when matter change into energy. Matter change into energy means if we have electron and we have positron, so particle and antiparticle, when they combine they form gamma radiations, means matter in this case will be converted into energy. That process we call is annihilation. Question 2 says there is a potential difference of 6 volts across a 220 microfarads capacitor. Which of the following expression gives the charge stored on the capacitor? Charge stored on a capacitor Q is equal to C times V. C is the capacitance of the capacitor, that is given to us 220 microfarads. So we can convert into farads, and potential difference is 6.0 volts. If we little bit simplify this one, we can also write on 2.20 times 10 to minus 4 farads, and here we have 6.0 volts. So the answer for this question has to be B. Question 3 says a nucleus of potassium 38 emits a beta plus particle. Which row of the table shows the proton number and nucleon number of the nucleus that is produced? So first of all we need to understand it is given to us this is beta plus particle. So it simply means that this is beta plus decay. So we can write on here potassium 19 and mass number of this one is 38. This decays into a nucleus and it also emits beta plus particle, mean positron, and it will also emit electron neutrino. To conserve lepton number, this has to be electron neutrino. This is antiparticle, so this has to be neutrino. Now from here simply we need to understand mass number on both sides have to be the same. So here we can say, and mass number of this one is 0 plus 0. It means mass number of this nucleus has to be 38, and charge on both sides also has to be the same. So here we can write down, and charge on this one is plus 1. Neutrino has no charge, so the charge on this unknown nucleus has to be 18. So this one is 18. We need to find out proton number. So proton number is equal to atomic number, so the proton number is 18. Nuclear number has to be 38. Nuclear number means the mass number, so you also need to understand nuclear number means mass number, the number of protons and neutrons in the nucleus, number of protons plus neutrons, mass number. So the answer for this question has to be B, 18, proton number, and nuclear number is 38. So the answer for this question is B. Question 4 says, which of the following gives the base units of impulse? So first of all, we need to understand impulse. What is impulse? Impulse is simply change in momentum, and change in momentum is m times delta v. So the base unit of mass is kg, and base unit of change in velocity is meters per second. So the answer for this one has to be A, kgs meters per second. Impulse and momentum, they have the same unit. So very important one, you need to understand these two quantities, they have the same unit. They have same unit. Question 5 says, scientists use particles with high energy to investigate the structure of nucleons. Which of the following statement is not a reason why particles with high energy are required? So in this case, we are investigating the structure of nucleons. Structure of nucleons. Investigating, very important one. To allow forces between particles to be overcome, yes. To overcome repulsive forces, particle must have enough energy. To ensure particles have a very high momentum, yes, they should have high momentum. To ensure particles have a very small deep wavelength. To study the structure, because the atomic spacing is very small, so we can say as atomic spacing is very small, then for diffraction to take place, wavelength also has to be very small. So this option is also correct. To provide sufficient energy for the production of new particles, we are investigating the structure. Our purpose here is not to form new particles. So this option is incorrect. So the answer for this question is D. Question 6 says, which of the following is a fundamental particle? Fundamental particle is a particle which cannot be further subdivided. So if you get given options, neutrino is a fundamental particle, means it does not consist of any smaller particles. So this is fundamental particle. Neutron is not a fundamental particle. This is a hadron, or we can say this is a baryon. It consists of one up quark and two down quarks. So this is not fundamental particle. Pion is a meson. It consists of one quark, one antiquark. So this is also not fundamental particle. Proton, it consists of two up quarks and one down quark, and it is a baryon. So it is also not fundamental particle. So the answer for this question has to be A. Question 7 says, a particle has mass 6.5 mega electron volts per c square. Which of the following gives the mass in kgs of the particle? So this mass is given in form of energy. We need to express this one in form of kgs. In order to answer this question, simply we need to understand E is equal to mc square. So from here we can say m is equal to E over c square. If E is in joules and c is in meter per second, then the mass we will get, this one will be in kgs. So mass will be in kgs then, kgs. Now simply we can write on here m. So how we can convert this one into joules? We need to understand 1 electron volt, or we can say 1 mega electron volt. 1 mega electron volt. This is equal to 1.6 times 10 to minus 13 joules. Minus 13 joules. So we have 6.5 mega electron volts. So we can write down 6.5 times 1.6 times 10 to minus 13 joules divided by, we have value of C, 3 times 10 to 8 square. Now if we simplify, so here we will have meter per second square as well, the unit, Now if we simplify, we will get the value of m. Now if you look at given options, if you look at option A, it is given to us 6.5 times 1.6 times 10 to minus 19. This is wrong because this is mega electron volt. If it was electron volt, this one will be correct. So A is not correct. 6.5 times 1.6 times 10 to minus 13. Yes, this is correct. So the answer for this question has to be B. This is incorrect. This is also incorrect. So the answer is B. So this is how you need to figure out. So you need to understand how to convert units. And this is very important one. You need to understand 1 mega electron volt is equal to 1.6 times 10 to minus 13 joules. You can also remember this one. 1 electron volt is equal to 1.6 times 10 to minus 19 joules here. So these are some important points you need to understand. Question 8 says, in the 20th century, scientists carried out alpha particle scattering experiments. Which of the following is not a conclusion from the scientist observations during these experiments? Option A says most of the atom is empty space. Yes, because scientists, they figure out that most of the atom is empty space, because most of alpha particles, they just went straight through. It shows that most of the atom is empty space and very few alpha particles, they bounce back. It shows that mass is concentrated in a very small size, in very small space, or we can say in nucleus, and charge is also concentrated in very small space. So option A is correct. The nucleus contains most of the mass of the atom. Yes, this is also true. The nucleus is made of protons and neutrons. Neutrons were discovered later after this experiment. So it means this option is incorrect. There is a concentration of charge in the atom. Yes, most of the charge is concentrated in the nucleus. This was one of the conclusion from this experiment. So the answer for this question is C, because this is incorrect statement. So the answer is C. Actually, neutrons were discovered in 1932, around this time. Question 9 says, which of the following shows the beta minus decay of a nucleon? For beta minus decay, you need to understand neutron decays into proton. So this is the important point you need to understand. Neutron decays into proton. So here we have beta minus particle, and beta minus particle is electron. So this is a particle. So there must be electron anti-neutrino to conserve lepton number. So this is what you need to understand about beta minus decay. If this is clear to you, now if you look at given options, neutron decays into proton, but this is electron neutrino. So lepton number is not conserved because this has lepton number 1, this also has lepton number 1, but neutron is hadron, it has 0 lepton number. So lepton number is not conserved. So this option is not possible. If you look at option B, neutron decays into proton, we have beta minus particle means electron, and we have electron neutrino. So the answer for this question is B. If you look at C and D, proton decays into neutron, this is beta plus decay. So this is incorrect. This is also incorrect. So the answer is B. Question 10 says, the diagram shows a current carrying wire between two magnetic poles. The magnetic flux density between the poles is 0.85 Teslas. Which of the following gives the force on the wire in Newton? So we need to calculate force on this wire, and force on current carrying wire is equal to I times L times B. So this L is very special one. This is length of the wire perpendicular to the field. So this is very important point. Length of wire perpendicular to the field. So we can say length of wire perpendicular to the field. So we can say perpendicular to the field. So this is the main point you need to understand. Perpendicular to the field. So in this case, force we can write down now. Value of current is given, that is 0.17 amps, and value of L we have to consider which value of L we have to take. So first of all, we can draw our magnetic field lines between these two poles. So we can draw a few lines to show this is direction of magnetic field. So this is our magnetic field. Now if you look at component of this wire has two components. One is this one, and one is along direction of magnetic field lines. So we have to take this component, and the length of this component is 5.2. So we can say this is 5.2 centimeters. So we have 5.2 centimeters means 10 to minus 2, and value of B is given to us, that is 0.85. So we can write on here, this is 0.17, and here we have 0.85 Teslas. So this is the magnitude of the force. We can also find out direction of the force. To find direction of the force, we have to use Fleming left hand rule. Means we have to use Fleming left hand rule. Fleming left hand rule. So in this case, we have magnetic field, so we can say B is down, so this is direction of magnetic field, and current direction is this way, and force on this wire is only due to the component which is perpendicular to the magnetic field. So simply we can say, so this component we have to take, this one we have to take, so this one, so this is our current. So now you have to use the left hand. So magnetic field is down, current is to the right, so it means force is into the page. So force will be into the page. So this is direction of force. So we can say force is into the page. So force is into the page. So this is direction of the force into the page. This can be the answer, this can be the answer, but this is not answer, this is not answer. Now if you look at given options A and B, this is right answer. So A is the right answer. Actually this is incorrect. This has to be 0.85. This one is correct, this is correct, this has to be 0.85. so this is just typo, this is wrong actually. So this one is correct, it has to be 0.85. so we can say this is correct, but this has to be 0.052, only this length, no sign. So it means this is incorrect. A is the correct answer. Here they have given you 0.85, but here they're using 0.085. So this is just typo. I hope this makes sense to you. If this makes sense to you, and if this video is helpful, please like and subscribe, because your encouragement is very important, and with your encouragement a lot of more videos will be coming very soon. So I will spare more time if you like and subscribe, and also leave some comments in the comment section. If you need more help and you are looking for extra resources, join Patreon. See you next video.